Okay, good morning and welcome everyone to the Pilot Developer Conference 2023. So it's really great to have everyone here in person. We've had the last 3 dev confs online, and while that's worked quite well, seeing everyone face to face and actually having the flying sessions and being involved directly looking at the hardware is fantastic. So very much welcome to all of you. And I hope you've had fun over the last few days. If you've been here for some of you got here on Monday, and we've had a lot of flying and a lot of excitement. So it's been great. And then we've got 3 days of talks now. I've got the schedule up here. The way it works is we've got 4 talks in the mornings, and halfway between those, so after the first couple of talks, we're going to have morning tea, which will be up the back there. So the morning tea will be brought in, part way through. Lunch is at 1 o'clock each day. It's also going to be a buffet up the back of the room. So, you don't need to leave the room at all. If you want to get a mattress and sleep here overnight, I'm sure that we could arrange that. So a few little things for this evening. The dinner's down by the edge of the lake at a place called the Jetty. Take a jacket. It could be a bit cool with the breeze over the lake. Just depends on what the wind is like there, really, with the over the water. But take a jacket just in case. If you haven't got a jacket, I've got a few extra jackets in my car, and so ask for one, and I'll get one out for you. On the Zoom, the speakers, as you come up with each speaker. So second speaker is Eric. If you could be ready with yours. Where's Eric hiding? There you are. Be ready so you'll connect to the Zoom call. The links for all of the Zoom calls are in the conference information sheet, that Google document you've all been hopefully looking at. And so join in that session and be ready to share your screen, but with your microphone off and your speakers off. Randy's doing the recording on his machine. So same for all the other speakers. Get set up on the Zoom. So we're live streaming. So we're live streaming now, and we've got people watching. Anyway, if each speaker gets ready before they come up and join the Zoom call. All right, so that's about it. So what we're going to do is give the first talk, and it just so happens that you're going to have to put up with me as the first speaker. So this is basically a systems update. I've given this each year during the dev conferences. Basically, it's a grab bag of all the things that are happening at the low levels in Pilot, the systems level, what's happening with the ports to the various boards, etc. And of course, there's been an awful lot happening. So we had 5,500 patches merged in the last year. 2,300 pull requests were put through. That's a lot of activity. Really intense. We have 2 calls a week where we have a whole bunch of developers to get together to discuss the latest PRs. And so clearly I'm not going to be covering all the changes in this. I'm just picking a few highlights and giving a couple of little demos of things that might be of interest to a technical audience like this. Oh, and it's great. The number of contributors we get each year is increasing. So 209 people have contributed to the main Pilot repositories and documentation in the last year, which is fantastic to see. And thank you also to all the people who've contributed documentation. Massive thank you to Henry, our documentation lead, but also thank you to all the developers who contributed documentation for the changes that they've been making. Okay, so system highlights, sort of a bit of an overview of some of the things that have been happening in the last year. So we've gone all in with Lua. We've had Lua support for now a couple of years. And that's the Lua scripting language embedded inside the flight controller. Incredibly powerful system. So we now support Lua Device Drivers. And I'm going to demonstrate a couple of those. And Randy's going to demonstrate one later in his talk about gimbals. What this means is we can actually have device drivers for real devices running as Lua scripts inside the flight controller. And that's fantastically useful. You've got a stable release of Pilot. You need a new EFI system, a proprietary CAN EFI, serial EFI, an I2C device you can now write that solely as a Lua script, and it integrates into the rest of ArduPilot and really useful. 32 actuator support got merged. Been talking about it for a while. Many thanks to Pete Hall for pushing that through, getting the final pieces done. And so there are quite a few vehicles now flying with more than 16 actuators, and was really needed for the larger, more complex vehicles. Complete rework of our notch filtering system over the last year. Filtering is incredibly important. I'll be diving into that a bit more in a later slide. Remote ID support, very important with the FAA mandate in the US and now coming in other countries. Again, thank you to all the people who helped out with that, and a bit more detail again on a later slide. We now have parameter defaults in logs and Mavlink. Again, I'll talk about that a bit later. Flashing the firmware from microSD. So you can now actually upload a firmware to a vehicle using Mavlink FTP, and then you can ask it to reboot and flash that firmware. Great for swarms of vehicles or remote access vehicles where you can't get a USB cable in. Incredibly useful feature. Many thanks to Peter Barker for arranging that. We have a new support system, support.ardupilot.org, and I'll be demonstrating that during this talk, if the demo works. And finally, Citylon hardware improvements. If you haven't used Citylon hardware, it's worth investigating. It means you can run the physics simulator directly within the flight controller. That was first introduced last year, but it's been greatly improved. So you can do quad planes and rovers and all sorts of other vehicles. And it means you can have a swarm of vehicles and have them flying the simulator, connecting just with a low bandwidth radio link, like an SIK or RFD 900, and fly the simulator. And the simulation physics engine is actually running directly on the flight controller. We've got enough CPU power on the H7 flight controllers that is practical. All right, so that's sort of an overview. By the way, feel free to ask questions while I'm going along. Just raise your hand or shout out, and very happy to address questions. And if that means we don't get to some slide, that's absolutely fine. Okay, so support.ardupilot.org. So we have this new support system. It's documented by just going to support.ardupilot.org with your web browser. And it's incredibly useful for the partner support team, but it can also be used by partners supporting their own users. And basically, this system allows us to ask a user from wherever they are in the world to forward their Mavlink. Now, we've had Mavlink forwarding for years. It's been possible, but it's been difficult and it hasn't been secure. So now we've made it secure using Mavlink 2 signing, and it's available. So any partner can request a support.ardupilot.org ID. And then there's documentation on how you can then support your users directly, get your end users to forward their telemetry link, and you then get your ground station connected to their vehicle wherever it is in the world. And neither the end user nor the support engineer has to have a public IP address. You can both be behind IP masqueraded, natted internet links. You only need outgoing UDP, which makes it very, very easy anywhere in the world. So I was going to give a quick demo of that. So here I have a vehicle here flying. I'm going to arm this vehicle, get it to take off. So what I've got is Mission Planner running on a VM here, and it's flying this vehicle. And then I'm pretending to be the end user here, and I need support. So we go into Setup and Advanced, and you'll see this little button, Support Proxy. You just click the Support Proxy, and it defaults to support.ardupilot.org. I was already connected, so I'll tell it to stop. And I say, connect to the support ID. The support engineer will tell you what ID they are using. So I'm just going to say 10001, which is my support engineer ID, and I go connect. And so then what I can do is go into my Mav support like that. So I am now the support engineer, and I am now receiving that telemetry, and I happen to be using Mav Proxy. I could be using Mission Planner to receive that, and that means I have full access telemetry. All of those packets are actually going via a cloud server in the United States. So out from my machine via that cloud server and back to here. And it's almost got the parameters down. It's taking a little bit of time. It's not a particularly fast link. And then once it's got that, I'll be able to so I can do something like get the waypoints up here, and that'll get the waypoints displayed on the map. And I've got the ability to provide advice or tuning support to the people remotely. So incredibly powerful system, very useful, available to any partner or any dev team member as a support engineer. So I'll just stop that. And you just press the stop button. You've got this little support pop-up box in Mission Planner, and you press stop, and it's now stopped forwarding. So it's no longer sending to that support engineer. All right, let's go back here again. So that's our support system. Yep. They can. So they need, I'm sorry, there was a question. Thank you, Josh, for can the support engineer make changes on the vehicle, change mode, change parameters? They can. The recommendation is the support engineer doesn't without talking to the user and explaining. So the way I always operate it is I'm on the phone to the user. I'm on a audio call of some sort, either a internet type link or a real phone call. And so most of the time, the support is actually done when the vehicle's on the ground in pre-flight, but I have done it with some vehicles where it's flying. And before I make every change, I talk into the pilot and say, I am going to raise that roll gain. I am going to do this. And I wait for them to acknowledge, yes, you're going to change that. Then you do it. It's very important to have that communication, that audio communication channel. Obviously, if it's a simulator at the other end, it's less critical. And it is actually very useful doing this with the simulator. I have helped people in many times sort out issues, for example, with real flight simulation, where they've got some issue in the vehicle, teaching them how to tune the vehicle, and I get them to forward the telemetry from the simulator to me, and then I can demonstrate the process of tuning a vehicle. It's a great way to teach. Any other questions about the support system? Yep. So it uses Mavlink 2 signing. So the way it works is that it's secure in the sense that without knowing the signing key of the support engineer, and every support engineer has their own signing key, without knowing that signing key, you cannot see any data from the user's vehicle, and you cannot send anything to the user's vehicle, right? So it's secure in that sense. It will only accept stuff with that signing key. But the packets are not encrypted, right? So if you are in a situation where knowledge of where you're flying must not leak out of the vehicle, this is not the right technology for you. In that case, you need a VPN or similar technology because the packets are flowing in the clear, but it's using the cryptographic signing of the packets to ensure that only somebody with the signing key is able to either receive the telemetry from the vehicle or control the vehicle. Now, the end user does not get the signing key. It's only the support engineer knows the signing key. It would be horribly insecure to tell all of the end users what the signing key is. And so individual support engineers, there's a page in our documentation that tells the support engineers how to change their signing key if they think it might have been compromised. Any more questions about the support system? Yep.
Forwarding of video as well?
It only does Mavlink. If you want to do video, you need to do it via some other system. Commonly, people use like a Zoom call or a Google call or Facebook, whatever you like. It doesn't do that. It's just low bandwidth Mavlink. It's also low latency Mavlink. The problem with the types of video links, etc., is you can get enormous lags, and you really want control to be very low latency. And that's why we structured in this way. Any other questions about the support system? Okay, so next topic, new parameter default system. And this is another one that seems quite trivial, but is in fact incredibly useful. And kudos to Pete Hall. We worked very closely together on getting this implemented. So what this is that ArduPilot now tracks what the default value is for every parameter. And it sends that when you do an FTP-based parameter download, it is sent to the ground station. And in every log file, every parameter that is logged in the log file gets both the current value and the default value. Now, the reason that's so important is it means that a support engineer can, on a log file, instantly go, what has changed? What parameters have changed from the defaults? What have they done on this vehicle? Because the defaults for different vehicles are different, depending on the type of flight controller, the exact firmware version, the type of vehicle you've got loaded, and the defaults actually are changed by other parameters. A good example is, say you've got a quad plane and you set it up as a tail sitter. The default gains on your VTOL controllers on a tail sitter are different from the default gains on a SLT type quad plane. And the parameter system knows that. And if you ask what has changed and it's set up as a tail sitter, it tells you what you've changed from the tail sitter defaults. So in other words, the definition of what the default is a little bit subtle. And I've put it there. The default value is the value you would have if that parameter had never been set, but all of the other parameters are at their current value. Right? So it's not the defaults if you wipe the board. For many of the parameters it is, but for many others it isn't, because there's a chaining effect where you change one parameter, it changes the defaults of the others. One of the obvious ones is an enable. If you do enable quad plane support with QEnable, then all of the quad plane parameters appear. They're not even in the defaults, they're not there at all if it's not enabled. So it's a little bit subtle there, but it's useful in the sense that when you're reviewing the parameters, you can see exactly what the user has changed. It's also live. So when I was on this link here, so I'm connected on a board here, and I can go param diff, and what that is showing me, this is the MAV proxy interface. It is available in Mission Planner as well. When I go param diff on this particular flight controller, it is showing me all of the current values of the parameters and the default value for every parameter. And I can do that with wildcard patterns like this. Show me only the changes, so maybe QA star. They're all the changes that I've made on this particular board for just the QA parameters. And you can see the first column is the current, the second column is the defaults. In Mission Planner's parameter interface, there's a little button, little tick box in the bottom right corner. And that shows you, that does the same thing and only shows you the ones that have changed from the default. So it's a very subtle change, but it's incredibly powerful for diagnosing problems, and it's one of the most helpful things for a support engineer. Any questions about that at all? Yep. That changes the defaults. Yeah. Yeah, that's right. So that makes that more useful. All right, Lua Device Drivers. I mentioned this at the start. Yep. Yep. You need to use the defaults.param embedded to change the default. Tom, question? Okay, so up the back asked, sorry, it's too dim up there. I can't actually see who it is. Right, James. Okay, so asked whether you can change what the default is and use the defaults.param file, which you embed in ROMFS. And there's documentation on the wiki how to change the defaults for your particular build. Yeah, that's right, or in the APJ tool. Okay, Lua Device Drivers. So Lua scripting, incredibly powerful system, but up till this year, we couldn't actually write device drivers in Lua. We now can. So we now have support for EFIs, so electronic fuel injection device drivers, gimbal device drivers, mount device drivers, and rangefinder device drivers in Lua is pending. Reshab's been working on that, and we should get it in soon. Reshab? It's there, it's merged. Ah, fantastic. Thank you, Reshab. I missed the merge. So fantastic. So that's now merged as well. So slides are already out of date. So this is particularly powerful for people who want to run the stable release, but add a new device that wasn't supported in a stable release. So for example, a new EFI system or a new rangefinder, then you can write a device driver, or the partner support engineers can help you write a device driver and add support for that new device. So it copes with rapidly evolving vendor APIs, supports serial CAN or I2C devices. So there's examples that emerged at the moment. There's the HFE and SkyPower EFI drivers, the DJI RS2 CAN gimbal driver from Randy, and the View Pro serial gimbal driver. So I'll give a bit of a demonstration of what that looks like in just a second when I move on to the next section, which is Lua Driver Testing. So Lua, we're sort of really stretching our wings with Lua over the last year. And one of the things that we've started to do is use Lua to drive hardware testing. And so we can actually create simulated devices in Lua, and then we can test the device driver, which might be a C++ device driver or a Lua device driver, using a Lua simulator of the device. So what I've got here is a demonstration of that. There is a Cube Orange here with its case off, and I have a CAN cable here connected in a rather unusual way. I have a CAN cable going between CAN 1 and CAN 2, loopback, right? So all the packets going out on CAN 2 go in on CAN 1, all the ones that go out on CAN 1 come in on CAN 2, right? So it's talking to itself on CAN. So then what I've got is I've got a Lua device driver for the SkyPower EFI system. And that is, you can see here that these are the parameters for that: EFI SkyPower enable, because of course Lua scripts can create parameters, and it can add parameters into existing subparts of the parameter tree. So this particular one is adding parameters under the EFI section of the parameter tree, adding the SP for SkyPower, enable, generator function, logging, rates, etc. Okay, so what I'm going to do now is demonstrate that. So running here, if I do this, then you'll see that I'm getting RPM. So this little board here is getting this sinusoidal RPM, right? And that is because I've got written here, I've got a little Lua script. If I list the Lua scripts on this board, so FTP list APM scripts, then you'll see that there is an EFI tester.lua, which is a Lua script that simulates multiple types of EFI systems. So this particular Lua script will do the SkyPower and HFE simulation. It creates CAN packets in the Lua script that mimic the behavior of the real SkyPower EFI system. And then I've got the EFI SkyPower device driver running on the other CAN port, and it's receiving those packets from the other side across between the two CAN ports. And that is then feeding into our EFI system. I have EFI type set to scripting, and I've now got the tester just produces a sinusoidal RPM and temperatures and pressures and all those things. I'm just showing the RPM, and that then appears on the board. So that means we can simulate devices in Lua and test our device drivers. And this can be used for testing either our C++ device drivers or our Lua device drivers. It's a very, very powerful technique. Any questions about that at all? Yes, Rishab.
Lua Drivers.
Yep.
This question come up again and again. That is it safe enough to have a critical component running in Lua?
Right.
Will my Lua script die in between and I'll be left with no sensor at all?
Right. So Rishab's asking, is it safe to run Lua device drivers? I believe it is. You've got to write, however, the device driver carefully. So you have to make sure that it handles all of the errors. We normally also write the device driver in such a way that, and just going to get rid of my silly email that keeps coming up here. And I have no idea where it's coming from. So somewhere here. All right. Okay. Let me kill that off. All right. So when we write these device drivers, if I look in drivers, for example, and EFI SkyPower, we run this thing called a protected wrapper. So if the Lua script, that's this part at the end here, if the Lua script died for whatever reason, it will automatically restart. So in some ways, it's safer. If you were to write a C++ driver and that driver were to die, a null pointer exception or something like that, then you will crash. That will bring down the whole vehicle. With a Lua-based device driver, it can restart just that device driver because of the way our Lua is sandboxed. So in that sense, it's safer. There is a risk of running out of RAM in Lua. So you have to make sure that you have plenty of memory given to the Lua script. So it's really only viable on H7 microcontrollers where you've got 1 megabyte of RAM and you can afford to be generous in the memory given to your Lua script to make sure it's not going to run out. And you need to write the device driver in a way that it doesn't continuously allocate objects, just like in C++. If you do a lot of dynamic allocation in your C++, then there is a risk that you'll run out of memory. If you do that in the Lua will shut down. That's better than crashing the board, but it will stop that device, although it will also restart again because of the protected wrapper. Okay. Any other questions? Yep.
Yeah, does it work with CAN devices only or can it be supported?
CAN, serial, I2C. Yep. We could do SPI as well. There's no reason why we couldn't do SPI, but the ones that we've had use cases for so far are CAN, serial, and I2C. It will support Ethernet. There's a very exciting talk coming up from Tom and Sid, where they're going to be talking about the Ethernet support in RGPilot. So once we've got that merged in, then all of these types of things will be on TCP/IP as well. So UDP, etc. All right. Yep.
How does it create the Lua Device Driver integrate nicely with the new support, like the default parameters?
Yes, they do. So when you the question was, do the parameters you create with a Lua script interface into our default system? Yes, they also interface into our documentation system now, which means you'll notice that if the developer has been bothered to document the parameters properly, and not all the scripts are fully documented yet, then all of the documentation for the Lua script parameters will appear in your ground station's parameter interface, and the default values are correctly recorded in. So it'll actually show you what changes you've got from the default values of the parameters created in your Lua script.
Everything works for the drivers, et cetera, that have been hosted into RGPilot being rebuilt, right?
For the documentation, for the defaults, it works for all of them. But for Randy's point was that it only works for the ones that have been put into our main repo. That's true for the documentation because we parse the Lua scripts to get the documentation, which we feed up to our firmware server, which is where you get the parameter documentation. So that should encourage you to submit your scripts back for inclusion. But so the defaults work for any Lua script. The parameter documentation only works for the ones that have been submitted back to our firmware server. Any questions about that at all? Any more? Yep, that's it. Sorry, John.
How do parameters defined in the Lua get their index for storage?
So the way it works is our original top level tree was an 8-bit tree, 8-bit index at the top level. And then we have 3 sub levels of 6 bits each, right? So we have 8 plus 6 plus 6 plus 6 bits forming a level 4 tree of parameters. The top level 8-bit, we expanded a couple of years back to 9 bits. There was one spare bit and we were able to leverage that bit, which means the top level is now 512, but we're only using 260 odd of it. So what we did was we reserved a couple of hundred range of top level for use by Lua scripts. And you'll notice that up the top here, that when I create the table, parameter table, you've got this parameter table key, that line 36 there. I don't know whether you can read that very well, but that when you create the parameter table, you give it that key and that anchors it at the top level, our parameter tree, and you can go down from there. And so it's stored exactly the same as our standard parameters, but they can be created dynamically, whereas our normal C++ doesn't yet take advantage of dynamic parameter creation. Although there is no reason why our C++ code can't do dynamic parameter creation as well. The APIs are there. It's just so far we've only been using it for Lua scripts. Any more questions about that at all? All right, let's go back on with the show. So the next thing I was going to show you, and slightly unusual in that showing off bugs. So there's been a number of bugs this year that we've fixed, and there was a particularly important one. I would classify it as perhaps the worst bug of the year. And so this bug was the bidirectional DShot Wrap32 bug. And it affected people using bidirectional DShot, which is already fairly unusual. That's not just DShot, but DShot with bidirectional transfers for getting RPM, typically used on small racing quads, but is used on some larger vehicles. And at the 71-minute mark, which is the wrap of the 32-bit microseconds, we had a bug where there was approximately a 1 in 3 chance of your motor output stopping. Now that's disastrous, losing motors in flight. So this was a major bug. But what I wanted to show you in this talk is some techniques we used to A, find and fix the bug, but B, using Lua to do hardware soak testing, right? Because once we fixed this bug, it was a probabilistic and it took 71 minutes to reproduce. We wanted to do thousands and thousands of cycles of testing, right? Which is not very practical. So with Lua, we can do that. Let me show you. So it's obviously fixed. All the stable releases have been fixed of this bug in the latest stable. So the diagnosis test technique is somewhat similar to the CAN one. You'll notice again an unusual configuration of this board, right? You'll notice that I have this little cable cross-connected between auxiliary 1 and auxiliary 6 on this board. Just a little DuPont lead going between auxiliary 1 signal and auxiliary 6 signal. That means the board can read its own signal, right? And it can read not just say, are we trying to send a signal, but by actually looping it back into another input pin, we can confirm we are actually getting the signal. Because when this bug bit, ArduPilot was completely oblivious to it. It thought it was sending signal, but there was a very low level thing going on with the DMA stream sources in the STM32H7, only affected H7, that stopped the signal getting out when the bug bit. So we loop it back like that, and then we have a Lua script. And I'll just turn on the Lua script and show you what it does. So what I'm going to do is I'm going to enable this Lua script, and you'll actually see the board rebooting. My apologies there. Just let me bring up my Mav proxy console window. All right. So what this Lua script is doing, and I'll show you the actual script in a section. I'll just explain the theory. So the Lua script, we added a feature to ArduPilot that allows you to boot ArduPilot at a time other than 0. right? So we can boot ArduPilot 30 seconds before the wrap. Okay, so it starts up at 70.5 minutes, just before the critical time. All right, so that means that the Lua script, when it starts up, it counts down to the wrap point, and it is reading that pin that's looped back and watching the BDShot signal and checking, is it getting BDShot coming out of that pin? And so it confirms the little script, if I show it here. So this is our wrap script, wrap test. What this one does is it counts the transitions on the pin to determine that it's BDShot. And it first of all counts down to the wrap point. And before the wrap point, it first of all confirms I am getting BDShot, I'm getting the D-shot signal. Then after the wrap point, it checks it's still getting the D-shot signal. And there's three possible answers that it can get. A fail answer, an error answer is where it doesn't get the D-shot in the first 30 seconds before the wrap. A pass is getting D-shot both before and after the wrap. And a fail is getting it before the wrap, but not after the wrap. And so what it does is this little screen you've got coming up here, which is probably a bit hard to read. This is it looking for the D-shot changes, and then it uses Lua parameters. So if I show the Lua parameters I've got here, this script creates a number of parameters, which is so it's got the count of the number of tests that I've done, and it's got whether it's enabled, how many errors I've had, how many fails I've had, and how many passes I've got, right? And which pin it's looking on. And so that's able, so now when it's then got past the wrap point, a few seconds past the wrap point, the Lua script force disarms and reboots, right? Reboots the board and it all starts again. And the state is stored in these Lua parameters. That means it's entirely standalone. You put it on the bench with that cable looped back, leave it overnight, you get a new test run every 45 seconds, right? With the boot time of about 15 seconds, which means you can do thousands and thousands of tests in a night. You have multiple boards in parallel on your bench. You can be very sure that if you've got, we did actually, Andy and I working on it together, Andy Piper in the UK, we got several thousand tests overnight before we pushed out the fix the next morning. And it gives us a way to be very, very confident. We also, of course, were looking with logic analyzers and looking at that type of level for signal integrity. But this was the bulk testing over a long period of time. So it's a very, very powerful test technique that I'd highly recommend you look into. You can do an awful lot with Lua script testing. So I'll just turn that off again so there's an enable parameter in the script. I'll turn it off so it stops rebooting my board here for more demonstrations. All right, so back here again. Any questions on that before we move on?
Could you find the root cause why it was happening?
Yes, we found the root cause. So the question was, did we find the root cause? Was there something else? Yes, the root cause was the H7 shares the same DMA channel for the outgoing D-shot and the incoming BD-shot. But one is called the UP channel, the other is called the IC channel. It's a different source to the DMA. So one is being generated by the UP timer for an outgoing pulse stream. The other is the IC input capture timer coming in from the edges on the timer back. And what happened was at the wrap point, it got a momentary timeout, and that timeout logic in the code did not reset the DMA source back to the correct one. So it was left on the input capture for the next D-shot output. When that happened, the next D-shot output also timed out. So it had the same bug again and again and again, 1,000 times a second. And so it continuously just didn't put it out, didn't put the output. So it was actually a one-line fix, although what we did was we made a larger change. We switched to 64-bit microseconds in all of that code as a belt and braces approach to be absolutely certain that all those classes of bug are gone. but it actually only needed a one-line change, which is at the start of the DShot output, to set the DMA source every time we start the DShot to guarantee that it's using the UP source from the timer, not the IC input capture. So we could have done it with a one-line fix, but we did the belt and braces fix to ensure that there wasn't anything else lurking there. Is that, yep. Any other questions at all? Okay, so moving on, filtering improvements. So filtering is incredibly important. After you do your thrust linearization on a VTOL vehicle, your next stop should be your filtering, getting the filtering right, then move on to the tuning. So many people do it the wrong way around. So get your filtering right. And our filtering over the last year has become much, much more flexible. We used to have just one harmonic notch filter. We now have two, which means you can set up one on, for example, the EFI RPM for an internal combustion motor, and the second on your VTOL motors. You could have one on ESC feedback, another one on a real-time FFT. So you can set incredibly sophisticated filtering strategies. Then within each of those filters, you've got a lot more flexibility with new notch types. So what I'm going to do briefly is show you our little filter tool that some of you may not have seen before. And so this is our filter analysis tool, which is at firmware.rgpilot.org tools filter tool. And what this tool does is you can set up all of the RGPilot parameters just the way you have it on the real vehicle, and you can also input what the throttle is for a throttle-based filter, or if it's an RPM-based filter, you can put in what the engine RPM is, and it runs our code and analyzes the filter, giving you the amplitude, the magnitude, and the phase at each point, at each frequency. So the frequency is on the x-axis. And what you're looking for is where you cross over around 90 degrees, where you start getting real trouble, at what frequency you start crossing over. Too many people put in really aggressive filters that get rid of all of the noise and make it nice and smooth, but it's phase lagged. It slows the signal down, and phase lag is what causes your oscillations. Phase lag is the killer. So you really want to make sure that you have your filters set up, and that's the point of using a notch filter, that it doesn't disturb the phase lag nearly as much at the lower frequencies. But it also allows you to play around with our new options. So I'll just go and set this as our original standard notch filter, and we can see there's a notch filter, right? We're seeing two harmonics there. You can see what's happening to the phase. You can see the magnitude there, the dip happening at the particular frequency we've got set up there. So that frequency is 45 hertz because I've got this set up at the moment as a 45 hertz frequency, and we're at the hover throttle, which it'll shift with the hover throttle. Now, that single notch filter is quite narrow. So some time ago, last year, we introduced the double notch. And if I go and turn on the double notch here with our notch options, there's double notch. And watch what happens when I calculate. I've now got a double notch like that, and then up and then down. So it's two notches next to each other. So what that's done is it's made it wider here, but right at the center frequency, you're not getting as much attenuation, right? So your filter is less effective at the exact frequency you want it, right? But it is wider. And for a long time, people were happy with the double notch. It did do its job, but there was this weakness that the attenuation wasn't as good right at the frequency you care about. So we've now got a go up to 16, and that will enable the triple notch. And if I recalculate that, that is now 3 notch filters next to each other, right? Which has now made it wider, but you're not getting that, you're still getting good attenuation right on the frequency that you want. So significantly better. So what this allows you to do is, often this is done by the partner support people analyzing your logs. This is the tool we use, but it's worth playing with the options yourself and understanding them, particularly looking at the phase lag. So for example, let's have a example here. So if I go to say, I don't know, 20 hertz here, and I look at the phase lag I've got 24 degrees phase lag at around 20 hertz. If I start putting in the gyro filter, and I put, say, a 15 hertz gyro filter, which I commonly see in people's logs, quite low pass filters, and they put them in there because it reduces the noise. And people think that less noise is going to be better. Let's see what happens when I put in that 15 hertz gyro filter and calculate. What that's done is that has attenuated more, but now if we look at 20 hertz here, we've now got, what have we got, 140 odd degrees of phase lag. That basically, that low pass filter, 15 hertz, beautifully smooth signal, but the signal is way behind in time at the frequencies we care about. And that gives you oscillation, right? So you've really got to watch your phase lag very carefully and craft your filters to fit the vehicle. There isn't one set of filters for everyone. Every vehicle is different. And this is the tool you can use to do that analysis and to understand what's happening to your phase lag. You can also, of course, add in your second filter. So I'm going to add in here a second notch filter. I'm going to make it an RPM filter from an EFI engine. And I'm going to set the RPM coming from that engine as 2300 there. And then I'm going to calculate. And what you'll see is here's the notch that we've got from that RPM filter coming in there, right? As well as the one from our vertical throttle. And we could then adjust, for example, we could make that, say, like 18 to do a triple notch, 16 for a triple notch, and calculate that. And we'll see then the effect of that triple notch coming in there and what that's doing. Incredibly powerful, and many thanks to the work by Pete and Matt and others on this tool. Very, very useful to analyzing what's going on in your filtering. If you haven't looked into the filtering in your vehicle, you should. All right. Any questions on that before we move on?
There's a question online, Tridge.
Yep, James.
Tim the Plane Man,
Question from Tim.
which is, what is notch filtering?
Okay, notch filtering. A low pass filter, like it sounds, is it removes noise, smooths the signal, starting at a low frequencies, and there's a notional cutoff frequency. So in other words, it just moves down all the, so that it only passes the low frequencies through and chops off the high frequencies. A notch filter, you can see these little notches. It's called a notch filter because it looks like somebody's taken an axe to your signal, and it removes the noise just at the frequencies where it's being generated, at your propeller frequency, at your engine frequencies. And so many vehicles that run Archipilot actually have lots of notch filters. They've got an octa-quad aircraft with ESC RPM feedback, that's 8 RPM signals. Then you might have a triple notch, that's 24 notch filters. Then you have 3 harmonics, that's 72 notch filters being applied to your vehicle. And if you do that, you want each of those notches to be very narrow, because if you put 72 broad notch filters, there'd be too much phase lag. And that's where you use this tool to analyze that setup. And you can actually set up an octa-quad ESC feedback in this tool and see exactly what the impact on the phase lag is. But it allows you to remove enormous amounts of noise. And then you can have your low pass filter much less aggressive, which means your phase lag gets much less and your vehicle flies better. All right, any final questions on that? Yep. Yes, indeed. That's the advanced topic here, is that further down the page, which I didn't go into, you can actually set your PIDs, your roll, pitch, and your PIDs, and analyze the magnitude and phase going through your PID. So you can see, for example, the phase recovery that you get with a D term. That's why you want D-term, because D-term gives you phase recovery. And as you raise your D-term, you'll actually see the phase lag decreasing. And as you add in I-term, you'll see phase lag increasing. So you can actually analyze the complete system all the way from the sensor out to the actuator using this tool. Incredibly powerful. Thanks, Paul. Yep. It's vehicle dependent. Depends on the control bandwidth of the vehicle. Rule of thumb, in like a quad plane, you should be aiming to get your gyro filter up to maybe 25 or 30 hertz, but it's very vehicle dependent. And sometimes you just have to have a low pass filter in there. Sometimes you need a very, very narrow notch around an RPM from a motor. I can't tell you what the minimum would be because it's so vehicle dependent. There are RG-Pilot vehicles, some of them weigh a ton, some of them weigh 200 grams. And the answer is very different for different types of vehicles.
In general, the bigger the vehicle, the lower the
Yep.
frequency.
That's right. The bigger the vehicle, the control bandwidth is lower, so the lower the frequencies you can go to and still have good control. All right, so let's keep going. And back to slideshow. Okay, remote ID. Big thing in the last year, getting remote ID up. Huge number of people helped. Jeff and Roll, Michael, David, Rob, Craig, Steve, all helped into enormous effort when the FAA said, okay, it's really going ahead. The legal challenges were unsuccessful. We have to have remote ID support. So RG-Pilot now has really good remote ID support. We have a new firmware, the RG Remote ID, and other vendors have brought out their own remote ID solutions. The Q-Pilot one, very notable, many of you might be using. And it all integrates into the open remote ID support inside RG-Pilot. That incorporated also secure boot. First time we've done secure boot in RG-Pilot, and that was required in some circumstances, read the wiki, for meeting the FAA obligations on tamper resistance. Ground station support, Mission Planner, QGC, and MAV Proxy all supporting remote ID, open drone ID. So that was a huge effort over the last year. Custom firmware server, we had this last year, but it's been enormously improved. Shiv, are you here? Yeah, so Shiv jumped in to help in this and has enormously improved this custom firmware server over the last year. We now, in the firmware server, we load the default options from the standard build. So if you ask on the custom build server to build plain cube orange, it will preload all of the options you would get with the standard build for that target and that board. And then you then adjust the ones that you want. It supports now both the stable and master branches. So that was contribution both from Michelle, thank you, and from Shiv. Fantastic feature. We also now have 224 selected build options. So I'll briefly go across and show you. This is our custom build server here. And if I go and add a build, then it's fetching all of the features. And so we can now choose, I want to do a copter latest, and I want to do it on, say, a CUAV X7 board. It's now got all of the options are automatically populated for what you would get on the standard build. And then you can then say, I don't want the MS4525. I don't need the Riken power generator, but I do want the intelligent Enery 2400 generator support. And you then go and generate that build, and it will build it for you and give you a RG-Pilot build, an APJ file ready to load on your vehicle. Incredibly powerful tool. Many, many thanks. Original implementation from Will Piper, then Michelle and Shiv have done wonderful work on improving this. You really should be using our custom build server. So I won't bother for it to finish building there. It's in the queue. All right, so back again. And okay, so 4.4 is just about to go out. We can now do missions on the micro SD card. That means the old 500 waypoint limit is gone. You can do 4,367 mission items. If people want more than that, it's a fairly easy change for us to push it up far beyond that. But it starts getting fairly ridiculous in the management of your mission. But you can, in fact, go up. We could easily change it to be far beyond that if need be. So log disarmed for on battery only, useful for developers, so you're not having log disarmed all the time. Parawong ESC support, throttle gain boost for VTOL, a very nice feature from Andy Piper. Synthetic current battery monitor from Henry. For people without a current monitor, it can synthesize a current monitor. The Unicorn EMEA GPS, a really nice new GPS that Holybro and CUAV are bringing out, both CAN and serial versions with support for L5 and dual antenna moving baseline directly in a single GPS. Jump tag support is a wonderful feature from Tom, makes you to create really complex missions, but much easier to understand and much easier to use with Lua scripting. Very nice work from Tom. And of course, Simon hardware. 4.5, we've just moved to a new Shibios release as of yesterday. Ethernet support. The star of the systems update really is Tom and Sid's talk coming up about the Ethernet support. And ROS2 DDS support. Ryan Friedman, hand up. Ryan. So Ryan's done fantastic work pushing on along with Ash, the ROS2 DDS support, and he'll be talking about that later in the conference. Lots of improvements, QSPI, and please remember, developers, keep your documentation up to date. And that is it. So just in time for finishing at the hour. Any final questions before we move on to the second talk?